Hey guys, so today we're going to take a look at section 9.4, which is all about logarithmic functions and equations. Alright, so we're going to start with our definition of a logarithm. So suppose you have a number b that's greater than 0 and it's not equal to 1. So that's going to be the base of our logarithm, just like the base of an exponential is any positive number other than 1. For some number n greater than 0, there is a number p such that log, the base here, of n is equal to p, if and only if b to the p power is equal to n. Okay? What does that really mean? So, in other words, an exponential can be rewritten as a logarithm in order to isolate the exponent. And the whole reason that we have logarithms is so we can go ahead and solve equations like the one that we saw in our last video, where we had 2 to a power equals 3 to a power, and we couldn't make the bases match, so we can only do it with a graphing calculator. Logarithms are going to allow us to solve that without using a calculator. Okay, so let's see what this really looks like. So if we have, we're just going to work from the definition there. We're used to seeing b to a power is equal to a number like 2 to the third power is equal to the number 8. We can translate that into logarithmic form. Okay, so the logarithm is written log for log, the base is the b, the n moves, and the exponent, or the power, p stands for power, is now isolated. So when I look here, the b is a 2, so this is log base 2. The number that it's equal to is 8, so log base 2 of 8 is equal to the power from the exponential, the 3. Okay? So that's how we convert between exponential form and logarithmic form. So we're going to go through a few examples of each. We're going to start with an exponential, write it as a log, start with a log, and write it as an exponential. So that's our first key skill that we need to be able to do. All right, so I'm going to leave the definition up there so we can see these two relationships, but I'm going to put up some new problems for us to try. Okay, so for these first few problems, we're going to express in logarithmic form. Alright, and you're going to hear me abbreviate logarithmic or logarithm with just log, L-O-G. Okay, so for the first one, we have 5 to the third power equals 125. So I want to rewrite that as a logarithm. Okay, so this is the base, this is the power, this is the number. Okay, so that means I'm going to do log. The base is a 5, so it's log base 5. The number that we're equal to is 125. The power, or the exponent, the thing we're trying to isolate, is a 3. Okay, so the 5, the base, is the base of the log. The exponent is what's being isolated. And what was isolated before goes inside of the logarithm. All right, so that's the structure. So I'm going to put up 2 more that I want you guys to try, and then I'll walk you through them. Okay, so for problem number 2, rewrite this in log form. 4 to the x power is equal to 32. Okay, don't solve for x, just rewrite it in log form. Okay, and then the third one, for problem number 3, back over here, I want you to do 1.7 to the x plus 1 power is equal to 4.9. Okay, so pause the video, take a minute, copy those down, and try to write them in log form. Okay, here's what that should look like. For problem number 2, we're going to start with log, L-O-G, And you're going to see me write my logs with a cursive L, just so I know it's an L and not a 1. If you prefer to write log like this, that's fine, but you're always going to see me write it this way. Okay. All right. The base in this exponential is a 4, so this is log base 4. I'm trying to isolate the exponent, so the exponent goes by itself at the end. What was isolated before, the 32, now goes inside of the logarithm. Okay. And for this one over here, log, the base in the exponential piece is 1.7. The exponent is x plus 1. That's what I'm isolating. And then the number it was equal to goes inside. Okay? So that's expressing from exponential into log form. And now we're going to work it the other way. I'm going to give you a logarithm. You need to write it as an exponential. Okay, and we're going to do 3 of those. Okay, so express each log in exponential form. Okay, so we're going to do 4 of these. So, 3 of these. Problem number 4, we have log base 7 of 343 is equal to 3. Okay. For problem number 5, I'm going to put that right over here. We're going to have log base, 10 of 0.001 is equal to x. And then for the last one, for number 6, we have log base 6 of 3 is equal to x. Okay? All right, so let's go through those. So this first one, remember, we're trying to write this as an exponential. So we need to identify what's the base, what's the power, what's the number. So this right here, this is the base. So the base is a 7. What we were isolating, that's the power, or the exponent. So it's 7 to the 3rd. What was inside of the logarithm, that's the n. So that's the number we're equal to, 343. Okay? So base, base. Isolated number is the exponent. Inside number is what we're going to isolate. Okay? So try the other 2. Right? And you should end up for number 5. The base is a 10. The exponent is x. The inside becomes what's isolated. Okay? Again, we're not solving for x, we're just rewriting it in the opposite form. Okay, so when I look at this one, I'm going to have the base is 6. The exponent is an x, and then the inside is what we're equal to. All right? So that's converting between log form and exponential form.